All right, so this video is going to cover this practice for loops with tables. And so I use tables to teach students how to run through loops. There is too much stuff going on in my mind to there's too much stuff and too many moving parts in my mind to just do this in your head, okay? And I get my high school kids want to fight this tooth and nail because they don't like writing stuff out, and I get it. I was their age once too, and I had no interest in writing out every single. Here, I'm gonna make this just a little bit smaller, and I had no interest either in writing all this stuff out by hand. But fact is, you're going to get the wrong answer if you don't do this, especially when you first start. I mean, if you've been doing this a while, you can maybe figure out the pattern in your head, but it's just too complicated in my mind. And this gets into, the meat and potatoes of programming with creating algorithms that run over and over and over until you want them to quit, all right? So anyway, what I do is I put all the variables in different columns, okay? And then, like, for instance, right here, there's A, okay, or there's I, set to A. But, like, when you get conditions, I'll put that right there. And then inside, we've got another statement that's doing something, okay? So A is 2, B is 4, C is 4, because C is set to B. And then I is set to A, which makes it 2. And then you just run through these, and you write them out. Is 2 less than or equal to 4? Yes, that's true. So then what do? We do C plus I, which is basically 2 plus 4, and that's 6, okay? Now, I wrote that backwards. Maybe I could write it over here, whatever. It's not a big deal. But anyway, I take that 6 right there, which is the new value of C, and I plug it in here. A is the same, B is the same. After this runs, then I increments by 1, so I is 3. We go back and we check, is 3 less than or equal to 4? It is. So we take the value of I, which is 3, and the value of C is 6, and that's now 9. This ends up going down here in my, right there. Okay, I gets, 1 gets added to I, so, 1 gets added, so that's 4. 2 and A and B stay the same, so it's 4 less than or equal to 4, yes. So you take the value of I, which is 4, and the value of C, which is 9. Add those together, you get 13. This comes down here into right there. I gets incremented by 1, and now is 5 less than or equal to 4. Nope, that's not true. So when this multiple choice question asks determine the output for the loop, afterwards it prints C. So final value of C is 13 right here, okay? And so if you write these out, then it's, this is manageable. This isn't that hard as long as you write them out, okay? So this next one, you've got F, and that's 0. You've got G, which is 1. You've got I is 0. And then I've got I is less than or equal to 5. And then you've got F equals F plus G. And then what do you have? G equals F minus G. Okay. So we check this, is 0 less than or equal to 5. That's true. So we add F and G and reassign it to F. So F is 0, G is 1, so this equals 1. So the new value of F is 1 right here. So then we get right here, the value of F is 1 minus G is 1 equals 0. So G is now 0. Then we go back up, I is now 1. Is 1 less than or equal to 5? Then we do, what's the value of F? F is 1 plus 0. And I need to do this too. I'm going to say first loop, second loop, third loop. I'm just going to put these in right now. Fourth loop. And obviously I've done this worksheet before. I've got the answers at the end somewhere. And then sixth loop, seventh loop. So I obviously did this, and that's why I gave you guys a table that had the exact, amount. But let's see here. Anyway, f is equal to 1. So I've got 1 right here again. And then what do we have? 1 minus 0, because g is 0, is equal to 1. So g changes to 1, I is 2, 2 is less than or equal to 5. And then what do we have for f? We got 1 plus 1 equals 2, so f is now 2. And then we got 2 minus, what's g is 1, and that equals 1. 1 gets added to I, so it makes it 3. 3 is less than or equal to 5. Then we got 2 plus 1 is equal to 3. And then we have, so I'm going to put 3 down here. And then 3 minus g, which is 1, turns g into 2. 1 gets added to I, so it's 4. Less than or equal to 5. So we've got what? 3 plus g is 2 equals 5. And then we got 5 minus 2 equals 3. What do we do then? I gotta put this down here. 5 and 3 and 5. So I becomes 5. 5 is less than or equal to 5. That's true. And then you get 5 plus 3 equals 8. And then is 8 minus, which g is 3. And that makes g 5. So we got 8 and 5 right here. And then I becomes 6. Is 6 less than or equal to 5? That's not true. So these are your final variable numbers, okay? And so what's the answer, or what is the question? Complete the table and determine the output. So it's printing f. F is 8, so your answer would be D. Okay. So you got A. I'm going to do the same thing here. First, second, third, fourth, fifth. And I wouldn't write this part out. You know, if I just had a blank paper, I wouldn't say iteration. First loop, second loop. But again, this is just demonstrating. You can do it if you want. It just depends kind of how much stuff you want to write out. But I would definitely write the variables out. I... And then we got what? I is less than or equal to B. And then what do we have? We've got this first if statement, which goes I modulus 2 equals 0. And then we have A plus equals 2. And then we do an A plus plus. Okay. So A is 1. B is 4, I is 1, and then what do we got here? Is 1 less than or equal to 4? So 1 modulus 2 equals, that is not true. The rule for this is if the left-hand side number is less than the right-hand side number, then return the left-hand side number. So the answer is 1, but mathematically to figure that out, you would do this. How many times does 2 go into 1? It goes in 0 times. And so then, okay, so the answer to this is remainder 1. That's how the modulus works. It finds the remainder. Now, if you had 2 modulus 1, is the left-hand side less than the right-hand side? No. So then you would do 1 into 2. How many times does 1 go into 2? It goes in 2 times. 2 times 2 is 2. Subtract that out and you get 0. Your remainder is 0. So the answer to this would equal 0, but the answer to 1 modulus 2 equals 0 is not true. So I'm going to put a cross through that. So it would not run this right here, but it would add 1 to A, and A would become 2. Okay? So then we come down here, we add 1 to I becomes 2. A is 2 now, and B is 4. And B never changes here, so, you know, if I want to, I could put 4 down for all of these, okay? So 2 less than or equal to 4. That's true. So 2 modulus 2 is equal to 0. So then we take the value of A as 2. 2 plus 2, and that's the new value of A, which is 4. So A is now 4. We add 1 to I, it becomes 3. Is 3 less than or equal to 4? Yes, that's true. Is 3 modulus 2 equal to 0. Well, how many times does you know, if we do it down here, if we did how many times does 2 go into 3? It goes in 2 times. 2 times 2. Sorry, it goes in 1 time. 1 times 2 is 2. Subtract that out, you get 1. So your answer is 1. So this is going to be untrue. And so what we're going to do is we're going to add 1 to A. A is 4, so A becomes 5. Okay. 1 gets added to A, or I. Is 4 less than or equal to 4? Yes, so what's 4 modulus 2? That equals 0. That is true. How many times does 2 go into 4? It goes in 2 times with the remainder of 0. So take the value of A, which is 5, and we add 2 to it. And then that is our new value of A, which is 7. So A becomes 7. And we add 1 to I becomes 5. Is 5 less than or equal to 5? Or 4? Nope, that's not true. So I'm guessing it's looking for A right here. So the answer to A is 7. B. Okay. And again, the answers I put down here. All right, so this one looks like a giant pain, right? First, now if you ever had one of these questions in class for like a quiz or a test, I don't think a teacher would ever give you this many iterations to go through on a quiz or a test. This is just kind of overkill, but that's all right. And I think I'm even missing some rows here. I'm definitely missing a row here, maybe just one though. All right, so what do we got here? We got K. K is less than 20. K modulus 5. It's 1. And it does what? C out. K basically. Okay. And then we add K. Okay, I forgot to get rid of that. That's fine though. All right, first time through, K is what? 0. Is 0 less than 20? Yes. So 0 modulus 5 equals 1. Well, remember I said last time, is 0 modulus 5, is the left-hand side less than the right-hand? Yep, so return 0. So this is not true, so we skip this. And then we do, 0 plus 2 is 2. So k is now 2. 2 less than 20, yes. 2 modulus 5 equals 1. Is the left-hand side less than the right hand? Yep, so return the left hand, which is 2. Is 2 equal to 1? No. So then we don't do that. And then we got what? 2 plus 2 is 4. 4 less than 20. 4 modulus 5. Is the left-hand side less than the right-hand side? Yes, so return the left-hand side 4. Is 4 equal to 1? No. So then we do what? 4 plus 2, and that is 6. Okay, 6. 6 is less than 20. 6 modulus 5. Okay. How many times does 5 go into 6? 1 time. 1 times 5 is 5. Subtract that out, you get a 1, so you get a remainder 1. So that is true, so we would print k. So k is what? 6. Then we do this. 6 plus 2 is 8. So how many times does 5 go into 8? 1 time. So it's going to be a remainder of 3. Is 3 equal to that? No, not true. So we got 8 plus 2 is now 10. Is 10 less than 20? Yes, so we got 10 modulus 5. So that's not true. It goes in 2 times the remainder of 0. So we got 10 plus 2 is 12. So 5 goes into 12 2 times with the remainder of 2. So that's not true. So you got 12 plus 2 is 14. How many times does 5 go into 14? It goes in 2 times the remainder of 4. So that's not true. Okay, 5 goes into 16 3 times. So this is true, so it prints 16. So it had 6 before, and then it's going to print 16 right there. So then we got 16 plus 2 is 18. It's 18 less than 20, yes, so 18 minus 5 equals 1. No, 5 goes in 3 times with the remainder of 3. So then we got 18 plus 2 is 20. So k ends up being 20. Is 20 less than 20? Nope, then you're done. So what's the final answer that it prints? 16, 6 and 16. Now, if you're on a time multiple choice test and you're sure that this is the first number, and you look at this and you go, well, A doesn't start with 6, C doesn't start with 0, D doesn't start with 4, and then you go, okay, B has to be my answer, and then you could just kind of think through, okay, right here is 16 modulus 5, just to test it for this second one to make sure that's true, but 16 modulus 5 and you get a remainder of 1, you go, oh, okay, that's probably the right answer. So anyway, but again, I have the answers down here, but I would highly suggest you write these out, even when you're coding. If you're having a hard time thinking through the algorithm with loops, you have to literally write this stuff out by hand in order to understand it. And in my mind, loops were, to me, this is where programming gets kind of difficult for a lot of students. It's kind of going to separate the people that want to program and the people that are just kind of in the class to, we get lots of cybersecurity students. That's fine. That's what their major is going to be in. Cybersecurity is not programming. And so they get to this part and they're like, ugh, I'm not going to be a programmer. I have no interest in it. And this kind of separates the people who really want to program and who really don't. And so the people that really do want to program, you're going to have to perfect this. And the best way I've come up with teaching this stuff is this table strategy and then step-by-step thinking through how to solve this. So anyway, this video's done.